Hi everybody, this is Mark Weitzman. Welcome to my YouTube channel, and this will be the my weekly blog on my YouTube channel and Piazza. And it's January 29th today. It's been a couple of weeks since I made this video. I'm close to 100% recovered from my cold, and that's why I haven't been making that many videos. But let me start this week. Anthony Z's book, Quantum Field Theory as Simply as Possible, is out finally. I think it's been out since the 17th. And on Amazon, I wrote a long review, also posted to my Piazza site, so you can read it. I really recommend the book for those who are interested in QFT, but it's sort of like an advanced popular book. There are actually equations in the book and everything, but it's not like a textbook, but it's not a completely easy read either. You'll learn something. And if you have a background in modern physics, relativity, quantum mechanics, you should be able to handle it fairly easily. He reviews those things, but very fast. Anyway, I recommend reading the preface, which is available. If you go on the Amazon website, you can read, like, not only can you read the whole preface, but you can read, about 30 pages of the book as well. So I recommend looking at that. Now, the next thing, I happen to be mentioned about 3 or 4 times in the book, sometimes by name, and sometimes, just as like a friend or something. But here I was mentioned because I mentioned to Tony Z that I wish I had had this book before studying Borkin and Drell at Caltech. And I was also mentioned somewhere in the book, in the middle of the book, he puts the Dirac Equation, and he writes it in modern notation like gamma u, the partial respect to u, and this might be hard for some people to understand. And I told him he should write it. He should add a friend. That's me. He said, add an equations where they're written in like 9th grade algebra, and he did. He added that to a note in the book. Here it is. This picture's blurred. It's not blurred in the book, but so this is how the Dirac equation can be written in component form. And it's not that scary or anything. It's relatively easy, 4 coupled equations, but that was my suggestion. And then finally, he put something that I posted one day in the New York Times when they got this thing about the mu on G minus 2 result. This was my thing that I posted on New York Times, and he put that in the book as well. So that's Tony Z's book. Most of the last couple of weeks, I've been reading, continued my reading of Colemans' book on quantum field theory, the lectures, and I'm now up to actually chapter 39, broken SU3 and the naive quark model. But as I started reviewing, introducing SU3 and irreducible multiplets and direct products, I realized that it's been a long time, since I reviewed group theory, and I had forgotten some of this stuff and some of the algorithms for doing this stuff. So, just to show you, Coleman does it really, really well. This is the isospin hypercharge decomposition, and these were things that always used to confuse me, but he does it in a way that makes it really easy to understand. So I highly recommend Coleman's treatment. And here you have things like the decomposition of an 8 by 8, an octet by octet is a 27 plus a 10 plus a complex 10 plus an 8 plus an 8 plus a 1. These were things that I haven't done in quite a while and probably need to review. So I decided to start reviewing and updating my notes on group theory, because eventually I've got a lot of videos to make on group theory. That's going to be another whole course. So I'm rereading and updating my notes on Group Theory in a Nutshell for Physicists by AZ, and Group Theory in Physics by Tung. This is another excellent book that I recommend. And then there's this old book, which is very hard to get a hold of. It was by a woman mathematician who passed away a couple of years ago at the age of like 98, Irene Shenestead, and it's hard to get this book. I happen to have it. But this is a real good book for deriving everything on the symmetric groups and the direct product representations. A lot of other books will show you the algorithms like hook and ladder and some other algorithms, but they don't actually derive them. This book actually derives it. So I don't know, on my Piazza site, Topics in Theoretical Physics, I have a section on group theory and physics, and I've just started updating my my notes, like the ones on Anthony Z. I've sort of updated them, and so I have about 60, 70 pages. The book is about 600 pages long, so I have about 70 pages condensed into about 10, 15 pages of notes, and these are all the sections that I haven't done, you know. Then I have some of his formulas also. Anyway, and I also, it's been a long time, but I do have notes on Tung's books. I probably have more notes here, but I skipped around on some of the chapters. Some are more complete. And it's just hard to make latex notes. It's easy for me to read a book and learn something, but to read a book and then take notes on it, I've never taken notes in my life when I learn things, and especially at my age now, I'm 66, I tend to forget things, you know, and that's why I need to make notes so that I don't have to reread the book every time I want to relearn something. If I have condensed latex notes at a like 5-to-1 compression ratio, that will help me a lot. So this was Tung's thing, where I have about 4 chapters into notes. And then Shenestead is like the hardest one because of her book was so old, it was written in script, and to get everything right, but I'm trying. I have some things done on this. You know, I even experimented with doing group tables, and I think I even have maybe some Young diagrams here and there, but obviously I haven't done much. Young graphs, yeah, there's a package in latex that does Young graphs, so I'm trying to, but you know, it's like I said, I kind of forget how to do this stuff. So that's kind of where it's at right now. I'm going to spend a lot of time on group theory. I'll do a little bit on quantum field theory. I know I have to update some, upload some videos on my QFT site on the path integral with for bosons and Grassmann variables. And so keep in touch, and thank you for watching the video. Bye-bye.